So the very first concept is of cross sections.
Okay.
Okay, I'm going to keep the same functions, y equals x squared and y equals square root of x. And what we will do is, between this region, let's draw the region.
Mm.
Let's draw y equals square root of x is this, and x square is this. Now, this is the region. Between this region, you have to imagine a solid, and you have to imagine that you're taking a cross section. Like this is a solid. You're taking a cross section like this. Imagine that this cross section is a square. This is a square. But you're looking at it from the top, so you are only able to see this line. You cannot see the square. Okay, and there are many squares like this. Okay, there are many squares. So this is another square. Okay, another square like this.
Okay.
Imagine all these square cross sections. That will give you a solid. It will be, I don't know if you're able to imagine this solid, but it will be a solid. Like if you look at it from the top, you will see a solid. And if we cut it, we get a cross section, which is a square. Okay. And now the problem is we have to find out the volume of this solid.
Okay.
Okay. So to find out the volume of this solid, what we do is we will find out the area of one square cross section. Okay. So we will find out area of one square. Okay. Let's say this square. And actually we are finding out areas of all the squares from this point all the way up to this point. I have drawn only 3 squares, but there will be infinitely many square cross sections. And we find out the area of one cross section, and we will integrate it. We'll add the areas of all the cross section. So that will give you this point, whatever is this point. Let's say this point is A and this point is B. So from A to B, area of one square. So that will be area dx. You're good till here? Okay. Now tell me, what is the area of a square?
A times B, or no, A squared.
A square. I mean, you mean the side square, right?
Yeah.
Okay. Now for this square, the side is this. This is the side of the square. Okay.
Yeah.
Can you find out what will be this distance between this point and this point? That will actually be the side of the square.
Oh, okay.
Let's say that
into the equation.
You
just put it into the equation.
Put what into the equation?
Like that point, like the x coordinate.
Oh, yes. Okay. But we don't know what will be the x coordinate. And this is actually just one square. The square can be even this as well, like this side. So not the x coordinate, you will take the y coordinate at this point minus the y coordinate at this point. That will give you the distance, this red distance, right? And this point is actually x comma f of x, because this point lies on the graph of f of x, and this point is actually x comma g of x. Okay, so if you just subtract the y coordinates, you get the difference, you'll get the distance. Okay, so your side will be the y coordinate, the top y coordinate f of x minus g of x. Okay, again, what you're doing, you're doing upper curve minus the lower curve. That will give you the side of the square. And if you square it, if you do s square, so f of x minus g of x, that gives you the area function. So the volume of the solid will be A to B f of x minus g of x whole square dx. And your f of x is the upper curve. This is square root of x.
Okay.
So A to B square root of x minus the lower curve is x square. And this is whole squared dx. And the points of intersection are actually 0 and 1. We found in the previous question, 0 and 1. So this is your setup to find out the volume. Okay.
Okay.
Now, in this question, we took a cross section which was perpendicular to the x-axis. Okay. The
Okay.
cross section, this was a cross section, it was perpendicular to the x-axis. They can also ask you to take a cross section perpendicular to the y-axis.
Uh,
Okay, so if you take cross section perpendicular to the y-axis, you will get something like this. This time you are taking cross section perpendicular to the y-axis. So this is the cross section, okay? Okay, this is a square. Like this is the base of the square. You cannot see the whole square unless you go in 3 dimensions. We are in 2 dimensions. We cannot see that. Okay, so you can imagine a solid, and these are, if you cut this solid with a knife maybe, and you're placing a knife perpendicular to the x-axis, so you'll get this cross section, a square cross section.
hmm.
Okay, and these are many squares, right? First square, second square, third square. So what we're doing is we are finding out area of all the squares from this point to this point, from 0 to 4, and we are adding the areas of all those squares, right?
Mhm.
But now your cross section can be also perpendicular to the y-axis, which is in this case. So this time you want to find out the side of the square. That means the distance between this point and this point. Okay.
Mhm.
Let's say that this curve is f of x and this curve is g of x.
Okay.
And this time it's very important. This time you will write the curve in terms of y, not in terms of x. Like here, we wrote the curve in terms of x, and integration was happening with respect to x. This time,
Okay.
everything will reverse. You will write the curve with respect to y, with respect to y, okay?
Okay.
And so you will do f of y minus g of y, and integration will happen with respect to y, so dy, okay? And the limits will be this point to this point this time. Now we are not dealing on the x-axis. Now we are on the y-axis. So this point to this point.
Okay.
Okay, so now let's convert the curves in terms of y. See, your f of x is x squared. That means y is equal to x squared. That means your x is equal to plus or minus square root of y. But on
Okay.
the right side, you have the positive square root of y. The left side, this one is x equals to negative square root of y, but you don't have to take the left side. You're dealing with the positive side. So this is square root of y. Okay, and your gx was square root of x. That means y is equal to square root of x. That means y square is equal to x. Okay,
Okay.
so this curve is gy is equal to y square. So your integration will be square root of y minus y square dy, and the y coordinate here will be also 1. See, this is 1 comma 1. So you have to take the y coordinate this time.
Okay.
But coincidentally, in this question, x and y both coordinates are 1 comma 1. So 0 to 1. Okay.
Okay.
Okay. So this is the square cross section. Okay, this was square cross section. Similarly, you can also have a triangular cross section.